Okay, so sorry for the interruption. So we're looking at the hardware components depicted in this block diagram. So the computer hardware is made up of inputs, the components that are called input devices or the input units are listed just above this block here. This is just a few examples, two of it, the keyboard and the mouse. Then you have the processing, that's the processing unit. Then you have the output unit and you have the secondary storage unit. And attached to the processing unit is the internal memory. We'll talk about this in a short while. Let's go on. Now here we look at characteristics of a computer. A computer is described as the wonder machine. Why? Because it processes data with speed, as I said earlier, reliability, the results must be reliable, accurate, versatile. The computer possesses versatility, and this comes from the programs, the software, different software that runs on the machine, on the hardware, to do different things. The computer doesn't suffer from fatigue. It's not like human beings that get tired. It's programmable, programmability. You can tell the computer what to do, can program it to do one thing or the other. That's programmability. It also stores and retrieves data and provides communication via network. The computer has a lot of advantages. The advantages listed here are may not even be up to all the advantages, because in today's world, computer actually is running the world in a large sense. So we have number one, the computer improves people's work-related lives. How does it do that? Yeah, I am working and I'm using the computer right now to give my lecture. So it's improving my work-related life. If computers can facilitate the upgrading of jobs, yes. Someone who maybe comes into work as a messenger, but decides to go to learn, upgrade himself educationally, gets to learn how to use the computer, maybe gets a computer training certificate. Of course, that person is good to go. The person's job will be upgraded. I mean, I started from the lowest rung, that's the messenger. It could be any level, actually. The more you get yourself, into the IT world, the more you are able to upgrade your job. Removal of the boring, tedious, and repetitive aspects of our job activities. Yes, that's a computer. You never find it boring. There's a lot to do, and it can keep you working and working for long hours. Computers can leave workers with the more interesting and rewarding components of their jobs. Yes. More like the third point, almost saying the same thing. Computers improve quality of work as workers incorporate computers in their work. So quality of work is improved. Where I could write with my hand before, I just sit in front of my computer system and I type. And I type and print that same document I would have written, and which would have taken me a longer time to write, and even will not look so neat, depending on how good my handwriting is. But when I print it, it comes out beautiful, neat, without any problem of legibility. That's how, whether it will be easy to read or not. Now let's move on to classification. Computers are available in different shapes, sizes, and weights, and they are used for different purposes. And based on this, we classify computers into the three different classifications. One is by purpose, by capacity and size, and by nature and type. Computers are classified. Let's take the first one, by purpose. Here we are saying what exactly is a computer designed to do. So we can classify computers according to what they are designed to do. So there are specific purpose computers, which are designed to perform a specific task. It doesn't do anything outside that specific task it is designed to perform. Examples are the digital calculator, traffic light control system, which you see on the road. No matter how many years the traffic light control system stands on the highway, it will not do anything else than just control traffic. Another example is ATM, digital watches, weather forecasting system. Next is the second type of computers classified by purpose. This is the one that falls under general purpose computer. As the name implies, is a kind of computer that can perform a wide variety of functions and operations. They have multi-purpose usage and application because they can execute different programs stored in internal memory. For example, you have computers that are used for business data processing, information management, and to write letters and play games, all in one computer. Does that one computer, you use it for your business, processing data that has to do with your business? The same computer, use it to manage information like staff information, or maybe student information or whatever. And then you have the same computer used to write letters. The same computer you can use to play games. You can even use it to watch movies. You can use it to listen to music, to play music. So a lot, that's a general type of general purpose computer. Then there is the computer that is the second classification, that's by capacity and size. These are grouped according to their physical size. These are computers, basically, you see, are grouped according to their physical size, how big, how small, how portable, and so on. Also, according to their speed, how fast can this computer process data? How large is the storage capacity? How much can it store at any given time? What is the cost? How expensive? And then the live wire. That's the users. How many users can sit on the computer at a time? So based on all this, we have examples of computers classified by capacity and size. You have supercomputers, you have the mainframe computers, you have the mini computers, you have the microcomputers. So we'll take them one after the other and see how far we go with them. We'll first look at mainframe computers. These are computers that were introduced in the late 1960s. They were very large, often taking up as much space as a classroom. Just imagine a whole big classroom that can take up to 40, 50 students. One computer is sitting there, taking up that whole space. That tells you how large. the mainframe computers were, or how large they can be, how big and large in size. But with their size, the large size also comes their large capacity. So they can store great amounts of information. Mainframes have the ability to run or host multiple operating systems, and they can do a lot of different jobs at one time. That's another advantage of mainframe. They can run or host multiple operating systems. What do we mean? In one mainframe computer system, you can have more than one operating system running in that computer. And also, they can handle different jobs at a time. You can batch the jobs. They could do, all the different jobs come in, and the same one computer is able to handle them. Remember the size actually is very large. The CPU speed of mainframes has historically been measured in millions of instructions per second. They are normally used by banks, airlines, large businesses, government agencies, and universities. And of course, even some big hospitals. I'm sure you are not surprised. Judging from their size, of course, and a single individual will not have any need for such a big machine. For instance, in developed countries, governments use mainframe computers to keep national database of citizens. And that's why, like in US, even if a citizen has committed a crime some years, a citizen commits a crime this year, and maybe thinks he has escaped the arm of the law. You discover that a year later, 2 years later, or even 3, 4 years later, that citizen is tracked down. That's because of their use of this such big, massive computer system to store their national database. Every information about every citizen is stored. Next, we have supercomputers. They were introduced in the 1970s. Supercomputers are mostly used for scientific work that require huge numbers of calculations. So you see their limitation. You can't use supercomputers for just anything because they are called supercomputers, and they are really super computers. They are the largest, fastest, and highest capacity computers, which cost millions of dollars, very expensive. They can process trillions of instructions in seconds. Remember, for mainframe, where mainframe is able to process millions of instructions per second, supercomputers can process trillions of instructions in seconds. They are designed to occupy special air-conditioned rooms and are used for research, worldwide weather forecasting, oil explorations, aircraft designs, and other sort of jobs. The supercomputers are designed to process huge amounts of data. So don't forget that. And that is why you don't just use them for anyhow. The next is mini computers. Now, between mainframes and supercomputers, which one is larger in size? From the slide, you can see that supercomputers are the largest, the fastest, and highest capacity computer. So whatever mainframe can do, supercomputers can do much more. But the mini computers came in late 1950s. They are much smaller in size than the mainframe computers. But they are, of course, larger in size than personal computers. They have terminals connected to them in the same room or building. Now, what terminals are Well, they are not full-blown computer systems. A terminal may just be usually made up of a screen and a monitor and a keyboard. So you have a keyboard, you have the monitor, so you can type. You may even have a system unit, but the data that will be processed will not be processed by the system unit. The data will be processed by the CPU of the mini computer. You have one mini computer, and you have small terminals, that connect to that mini computer, maybe in the same room or in the same building. And then we have the smallest of them is, so far we discussed, is the microcomputers. These microcomputers can handle more inputs and outputs than personal computers. They also came in the 1970s, actually, when the microchip came on board, came into the scene, because the microchip could, squeeze in so many transistors, squeeze us into as integrated circuits and then into a small space, so that instead of having big, massive computer like that, you can have a microcomputer. So that's how the microcomputer came. It can handle more inputs and outputs than personal computers. Microcomputers are small, inexpensive computers. They are easily moved around. You can move your microcomputer around. They can do one work at a time. That is one limitation of microcomputers. They can handle one work at a time. Unlike the mini computer that has several terminals connected to it. And remember, each terminal will have a user, a human being sitting to operate it. So if you can have a mini computer having up to 20 users accessing that mini computer at the same time via their various terminals. But for microcomputers, it's not like that. It's just one CPU, one VDU, one keyboard. Everything is one user at a time, one job at a time. So you can see terminals cannot connect to them, cannot be connected to microcomputers. Examples of microcomputers are given here: desktop, network computers, laptop, palm-top computers, and PDAs, that's personal digital assistant, and tablets. The third classification is by nature or type. Remember how we came? Classification by purpose, classification by size, and capacity. And now we are on to classification by nature or type. By this, we are looking at how computers can be grouped into the way data is presented. That's the mode of operation of data in the computer. Now, there are three main ways that data can be presented in the computer or by a computer. One is analog, the other is digital, and then we have the hybrid. And now, these different ways of presenting data, it's now what gives rise to the type of computer we want to look at next. So you have digital computers, you have analog computers, and you have hybrid computers. Now, digital computers use digital signals which are discrete and expressed as electrical pulses. Electrical pulses. Discrete comes as maybe 1, 0. Information is represented using the digits 0s and 1. So for a digital computer, there are only 2 states. There can always be 2 states, either of 2 states. You cannot have the 2 states at the same time. So it's either the computer is on or off. It's either there is data or there is none. It is either that Is there is signal or there is no signal. So that's why we have a 0 and a 1. The 0 represents the off state. That's the absence of the signal. And then the 1 represents the on state, which is the presence of a signal. A digital computer is composed of 5 distinct units, which are the processing unit, the input unit, the memory storage unit, the output unit, and communications network called a bus, which links all the elements of the system and connects the system to the external world. Examples of digital computers are supercomputers, which we've just discussed, mainframe computers, mini computers, workstations, and microcomputers. So basically all the different classifications of computers that we discussed are all digital computers. Now, let's take a look at analog computers. Analog computers are used to process analog data. Now, this is data in the form of continuous variable physical quantities. They represent data as variable across a continuous range of values, that is in a continuous electrical signal in form of waves. Now, you see, there's a lot of grammar here, but can you just imagine the electric bulb? Imagine a white fluorescent electric bulb. The fluorescent light bulb is usually long, and when current is flowing, when there is current flowing into it, which lights up the bulb, if you look at the bulb, you will see as if something is moving inside. It's moving in a wave-like form. That's the electric signal. That's the electric current moving. So it is that type of signal. Now, imagine it that can you measure it? Can you say at this point, the electric signal that is flowing is 10 or 1 or 2? No, you can't measure, it can't be measured that simply. Now, also take a look at an example of a water tap. Water is flowing from the tap. You can only just watch it flow down. You cannot catch that water at any given time as the tap flows and say, this is 1, this is 2. It's not possible. Okay, I'm using physical quantities now, physical things to try to explain what the analog computer, what analog signals are. Analog signals are signals that come as continuous electrical signals in form of waves. They go in wave-like form, like this, okay? Like this. They go down, go up, go down, go like that, like a flow, Take an example also, okay? There's even the example here. Temperature, speed, voltage, pressure, weight, depth. Have you ever gone to measure your temperature at the hospital and they use their thermometer, put under your armpit or put it under your tongue, depending, and then bring it out. When the doctor or the health practitioner lifts the thermometer that has taken your temperature, lifts it up, there's no way he or she can read and say, oh, this is 1, your temperature is 1, or temperature is 2. But what he sees is a flow, You will see a flow, and then he will now read where the flow stops. Because the thermometer has been calibrated, so where the flow stops, he will read it off at that point. That's how he will be able to say your temperature is 30 degrees or 27 or 35 degrees centigrade or Fahrenheit, as the case may be. Okay, that's just an example. The same goes with speed, voltage, and so on. Now, examples of analog, sorry about that. Examples of analog devices and computers are telephone, your handsets, computer speaker, as I'm using, iPod earphone, Mark 1 fire control system, the slide rule, and so on. Now, how about hybrid computers? It's a computer that is designed to provide the features and capabilities of both digital and analog computers. Anytime you hear hybrid, just think fast and know that we're talking about a combination of more than one thing, two things or more, hybrid, two things or more coming together. So when you have the advantage of this, bring together, and then it gives you a hybrid whatever. So now we are talking about a hybrid computer. It offers a much cost-effective method that is used to perform complex simulations. The digital component serves as the controller and provides logical operations. An example is the computer used in hospitals to measure the heartbeat of patients. That's a typical example of a hybrid computer system. Now, I would like you to think, how does it work? How does it work? Remember, a hybrid computer takes the advantage, the features and capabilities of a digital computer and that of analog computer and combines the two. So that's a very wonderful computer system that you can have. And you know, the heart of individuals, of human beings, the heart is a very complex organ. So it can only take a hybrid kind of computer to be able to measure the heartbeat of patients in the hospital. So let's move on to components of a computer. Well, there are just two main components, the hardware and the software. The hardware is the physical components of a computer system. Those components that you can touch, you can see with your eyes, you can move with your hand, move it from one place to another. That is, in a short form, the machine itself, the physical machine. That's what makes up the hardware. That's the hardware. The machine itself. Then you also have the software. The software is unlike the hardware. It is the program, the set of instructions written by programmers to perform specific tasks. Software provides logic that directs the machine. Software provides the logic that directs the machine. What does that tell you? If you don't have software, no matter how beautifully packaged your hardware is, the hardware can do nothing without the software. Similar to, you have a beautiful car that runs on fuel and there's no petrol anywhere, you cannot pour water into your car and move the car. It's not possible. So that beautiful car, that expensive car will sit down there and be looking at you. You have need for a car, but you can't use it because that which powers the car is not there. That's the petrol. And if it's an electric car, if there's no electricity or enough charge battery, you can't also run the car. All right, so let's take a little look at the hardware components. We've seen that a computer system is typically divided into two major components, the hardware and the software. So now let's take a little look into the components of the hardware. Hardware components can be grouped into 5 units. These units we've seen before: the input, outputs, processing or system unit, the storage unit, and communications units. Each of these units is composed of various devices. So here is a picture of a typical hardware showing the different components. You have the system units. This is the system unit. On a typical desktop, in an office computer, in an office, I'm not talking about a laptop now. You will find a system unit like this, as you can see, my arrow, that box, the box you see either standing or sitting on the table or sitting on an elevated floor where it has been provided for it to sit on. So that's the system unit. We'll discuss it in detail later. You have speakers. These speakers, of course, are used where you want to play music, or you're listening, you're watching video, or you are communicating to someone and you need to hear each other. You need the speakers. Then you have the monitor. The monitor is as the VDU, the visual display unit, the visual display unit. It is that component that visually displays or displays the result of processing for you to see. It displays the result of processing for you to see. And then you have the keyboard, which is what you use as a user to key in your data, your input into the system. And then you have the mouse, of course, also, which you use as an input device also. Now, this is a typical computer system with its attendant hardware. But many systems, when you go to buy, may not have. Speakers are actually addendums, what we call peripheral. It's a peripheral. You may buy a computer system without this.
Ma,
yes.
Ma, I want to ask you for system unit. I don't understand what you say.
Okay, this is the system. Can you see the system unit?
Yes, I'm seeing.
Okay. Now, the system unit is the box. You can also call it system box. Is the box that contains the CPU, the central processing unit. Now, I was saying that if you enter an office, a typical office, where the office is not using a laptop, but a desktop, you will always find a system unit. And I want to believe even in your labs, when you go to lab, on the table of the table in the lab, you will find your monitor, right? Are you there, Musa?
Yes, ma'am.
Yes. Good. You'll find the monitor, that's the VDU, that's your screen. And then you find your keyboard, you also find your mouse. All these sit on your table. But below the table, you should find a system unit, that box that stands there. That's where maybe you want to copy something with your flash, you want to use your flash, you insert it there. Have you ever seen it? You haven't seen it before? Have you seen it before?
Yes, I'm seeing.
No, have you seen it in the lab, in the computer?
Yes, I'm seeing.
Okay, very good. So that is the system unit. It's called the system unit. Inside it, you have the motherboard, CPU, and all the other things we are going to discuss later. But I just wanted all of you to get to know that this is what you find. The typical hardware component will always have the monitor, it will have the system unit, it will have the keyboard, it will have the mouse. Now, even if it doesn't come with speaker, there's no problem. You can buy your speaker and as a peripheral to add to your system. Is that okay?
Yes, ma'am.
Okay, good. Again, there's another picture on the next slide. We are still talking about hardware. We've talked about speakers before. The speaker is an output device. There are two speakers again. And then your keyboard is an input device. The monitor is an output device. Then where your computer has a camera, the camera is an input device. Now I'm able to do what I'm doing because I'm using a laptop. My laptop has a camera. If my laptop doesn't have a camera, I won't be able to do this Zoom. You won't see me. And I won't be able to see you people when you come into the online class, okay? Now here also we have the microphone, which is an input device. Then you have a mouse, which is also an input device. So on this picture alone, you can find 3 input devices: the keyboard, the microphone, and the mouse. They are all input device. And then the 4th one, the PC camera. That's where there is a camera. So it comes into as an input device. And here also you have the speaker is an output device. The monitor is an output device. Now there is no printer here, so I cannot add the printer at this point, but we are still going to talk about these devices in detail. And here, this is again the system units. You can see is a little more detailed now. Inside the system unit, you have the processing unit, that's your CPU. You have the memory, internal memory, and then you also have the storage unit, that's the external storage. That's the slot where you can insert your flash, you can insert your CD if you want to copy something either in or out of the computer system, or you want to save your work on a flash. All of them find space on the system units. And you have miscellaneous storage devices. These are, if you see this arrow, this 1 and 2 are for your CD. These are CD drives. CD drives 1 and 2. It has 2 CD drives. Then this one here is a disk drive. It's a disk drive. Now, where you have a disk, we call it diskettes. Unfortunately, well, not unfortunately, technology has moved on from diskettes. So you don't find diskettes in use anymore. But when diskettes were in use, this served as the disk drive where you can insert your diskette and use it to either save your work or retrieve something from the disk into the system. And then, of course, this is a digital camera again, which you can buy as a peripheral. If you have it as a peripheral, then you can now, add it on. That's if you didn't come embedded with your system. And then on this side, you have the modem. Modem is for communication. When we get to communication, I will explain this better. That's modulator, demodulator. I'll explain it better, okay? And now we have annotated diagram. Annotation means detailed, labeled. You can see it labeled, the 1, 2, 3, 4, 5, up to 14 tells us what is what. I've talked about speaker, so you can now relate each of them to what they are on the diagram. But I want us to look, we know speaker, modem, microphone, the ones you can already identify on your own. Let's leave them out. But now let's look at RAM. Number 4 is RAM. Number 4 is RAM. And here you find the RAM. These are the RAM slots. This is the place where your RAM is slotted, is inserted. Oh no. Oh no. Musa, the light is gone. Oh shoot. Hello, can you still hear me? Hello, Musa. Hello. Oh dear. Hello. Hello. Can anybody still hear me?